Welcome to Academic Digest class. So the question before us says, give the derivation of sin 2 theta equals to 2 sin theta cos theta. In order for me to do this, I have to draw an equilateral triangle. 60 degrees, 60 degrees, 60 degrees. But let's say we don't know it. So when I divide this triangle into two equal halves, let's say I call here A, let's say I call here B, let's say I call here C. A is facing this side, A, and B is facing this side, C is facing this side. There's an angle here. There's an angle here, which I know 60, 60. But let's say I don't know it, so I call it alpha, alpha. This angle here and this angle here all gives me 60 degrees. Let's say I call this alpha, let's say I call this beta. So in trying to prove or get this equation, these two equations, what we normally call it is the double angle trigonometry or the double angle identities. So I'll take it that this is alpha and this is beta, or you say theta, theta, but I want to call it alpha and beta so that we know for a fact that they are separate. Then after we put it together, better understand me. Now notice that this part, this is one part, which is A alpha, C. Now let's say the height of this triangle is H. So I can say this is H, this is B, and this is A, the small a. Or let's say I call this side X and call this side Y. Or let's say I call this side P, sorry. And let's say I call this side Q. So this is A. So let's say this is now P. And this other side, what I'm doing is just the equilateral triangle, I'm dividing it into two equal right angle. So I'm dividing it into two equal parts. But you see that when I divide it into two equal parts, it's looking like a right angled triangle. This way, because anything that has to do with straight line this way, straight line this way is 90 degrees. You need to know that in straight line. So I have H, I have B, I have C, I have E. This is my E, this is Q, this side, everything here is Q. So why am I doing this? The reason I'm doing this is so that I can be able to get sin A. And you know that A in itself is equals to alpha plus beta. I can see very well that alpha and beta gives me this A. Only this side is beyond this. So if I know that, so that I can be able to get sin A, which is sin alpha, sin beta. Also get cos A, which is cos alpha, cos beta. Also get sin B, get cos B. Then get sin C, get cos C. So these are the things I want to do that is making me do this. And when I'm done with that, I'll still get the Pythagorean identities. What do I mean by Pythagorean identities? Like if I come here now and I'll say, what is C? This hypotenuse, C square is equals to H square plus this side B square. And then this one that is here, B square is equals to Q square. You know I want to put it so, but I want to do B square plus X always comes before Y. So this one is supposed to be X. So this one P square is equals to Q square then plus H square. So now that I've done this, now if I'm done with this, everything I have here, I can also expand this thing I have here from this one. From this one, I can expand this to have, when I make P subject of the formula, I'll have P square is equals to C square minus H square. And when I make H square subject of the formula, I can have H square is equals to C square minus P square. And from this one, when I make Q square subject of the formula, I'll have Q square is equals to P square minus H square. And when I make H square subject of the formula, I'll have P square minus Q square. So from what I have up here now, let's do this. These are things I have to get before considering this. So now I will now say, to get sine alpha, since A is equals to alpha and beta, so to get sine alpha will be equals to get sine alpha, let's check this. Alpha now, opposite over hypotenuse. Alpha will be, sine alpha will be opposite is P over hypotenuse C. So P over C. Now let's get cos alpha. Cos alpha will be equals to adjacent over hypotenuse, which is H over C. Now let's get sine beta. Sine beta will be equals to, this is beta, opposite over hypotenuse, that is Q over B. Then cos beta will be equals to adjacent over hypotenuse, which is H over B. H over B. Now for sine beta, sine B, this is B, this is the angle sine B. Opposite of sine B is opposite H over C, opposite of hypotenuse. So sine B is H over C. Then cos B, adjacent over hypotenuse, that is C over P. Adjacent cos B, adjacent over hypotenuse is P over C. Are you crazy? P over C. Then sine C, this is C. Sine C, opposite over hypotenuse, H over B. Cos C, adjacent over hypotenuse, Q over adjacent cos, Q over B. Remember, this is H. So you don't confuse it. So now that I've gotten all these trig ratios for this triangle, I can now go on and do the sine. Now notice, sorry, I can now go on and do the addition. So I can now say sine alpha plus beta is the same thing as sine 2 theta. This is a theta, this is a theta, two angles. So now if I know this will be equals to, and anytime the angle is above 90 or less than 90, notice that the angle here is less than 90, we use the sine rule and not the SOHCAHTOA. So the reason I'm using sine rule is that this angle here that I'm looking at for beta and for alpha is less than 90. Anytime I'm using angle less than 90, I do sine A all over the corresponding length, that is this A over the corresponding length, which is A, is equals to sine B all over the corresponding length. The corresponding length of B is this. So if I know this, it can also be equals to sine C all over, but whichever way, at the end of the day, you are putting the twos together. So it's only 2 you do at a particular time, only 2, you won't do the 3. So I could just say equals to sine C over C, but at the end of the day, I'm doing 2 sides at the same time. So this is going to be the same thing as same. Sine A is sine, okay, alpha plus sine A is the same thing as sine alpha A is equals to sine alpha plus beta all over A in itself, A. If you notice, A here is equals to everything here, and everything here is P and Q. So A, so note, A is equals to P plus Q. So I'll do P plus Q is equals to sine B. B is equals to H over C. So then all over B, so divided by B, that is divided by B, this B, and B is not equals to anything. This is B is not equals to anything. So if I know this, everything on this right hand side will be the same thing as saying h over c times, because this one times 1 over b. So the same thing as saying h over cb. So that means that sine alpha plus beta over p plus q is equals to h over cb. And this can be the same thing as saying this can be the same thing as saying cross multiply, so that I have sine alpha plus beta is equals to cross multiply, but don't carry this up to here, just take this to this place, so that I have h into p plus q all over cb, all over cb. So if I know this, okay, I just needed to light up the room. So if I know this will now be the same thing as saying that we can continue this to say that it means the same thing as saying sine alpha plus beta is equals to h into p plus h into q all over cb. And if you do it well, this is going to mean the same thing as saying hp over cb plus hq over cb. So this is the same thing as saying h dot p all over c dot b plus h dot q all over c dot b. Alright, now we'll go back and check. When we started, what is h over, from what we have here, h over c? Do we have anything like h over c when we listed out the things we have from this triangle? Anything like h over c? That is for alpha and beta. Notice that I'm not looking at b or this, just for notice that what is equals to, I'm looking at sine alpha plus beta. Sine alpha plus beta, that is what I'm looking at. So if I know that sine alpha and beta, I'm trying to get sine alpha and beta to be equals to what is on the other side. So sine alpha and beta, that is what I'm looking at. So I'm going to be checking the ones that concern sine alphas, cos alpha, sine beta, and cos beta. Do I have anything? Does he have anything like h over c? Yes, h over c is cos alpha. H over c is cos alpha. Okay. What of p over b? P over b. P over b. I don't have anything like p over b. What of h over b? Okay, I have h over b. So I can also say that h over b, that is h over b, this one now, h over b, h over b. So see, I have h over c to mean cos alpha, but I don't have p over b. I don't have p over b. So for that reason, I will rotate this to be the same thing as saying h over b dot p over c. And if I know that, it will now be plus. Notice that right here I have h over c and I have q over b. Because I've not come across that, I can now say h over c and then q over b. So let's now check. For what I have up here, that is down here, I have h over b to be cos beta, and p over c is sine alpha, plus h over c is cos alpha, but q over b is sine beta. So see where my eye is. Are you seeing it? So everything about alpha and beta, this is it. So if I know that, I've replaced this. So we can now say that sine alpha plus beta is equals to cos beta times sine alpha plus cos alpha plus sine beta. So remember, this is where I started. This then I moved on to continuing it this side. So you can now see that if this is the case, this is now the same thing as saying cos beta plus cos alpha dot sin alpha plus sin beta. So this, let's say this is theta or AA, theta. So this is plus sin. So you can see that this is the same thing as saying 2 sin theta dot, this is cos theta plus cos theta because it's angles. So if that is the case, we use beta and alpha. Notice that beta and alpha that we used, they are both equals to 30 degrees up there, if you remember. So 30 degrees, they are the same thing. So that's why we just used alpha and beta to be able to make the differentiation. So if you know that this is the same thing as saying 2 cos theta dot this. So if you put it together, you see that this is the same thing as saying times. So this is the same thing as saying bring the 2. 2 is common to the 2. Bring the 2 out, you see that this is cos theta, cos theta sin theta. So this is why we say that sin 2 theta is equals to 2 cos theta sin theta. So hence we've been able to derive it. So we can also say that sin alpha or sin alpha beta is equals to 2 cos. Yes, you can see that it is the same thing as saying 2 cos alpha. Yes, then sin alpha or 2 cos beta sin beta, because alpha is equal to beta. Alpha is equals to beta equals to 30 degrees. This does not mean that it will always be 30 degrees. It can be different, but in this case where I have this, notice that the angle and the angle I call here is 30 alpha beta. So it can be different. It can be different angles, but those angles are the same, provided the angles, the theta is the same. Provided the theta is the same, sin 2 theta will always be equals to 2 cos theta sin theta. Proved. So in order to prove the second one, which is sin cos 2 theta equals to cos square theta minus sin square theta, all we just need to do is to employ the cosine rule. And what is the cosine rule? Cosine rule is simply cos, from secondary school, if you remember that time they normally do for you, r square equals to x square plus y square minus 2xy cos theta. So in this case, it's going to be stated as saying a square equals to b square plus c square minus 2bc cos a. And the angle, the a here is talking about the angle for a. So it's all about the sides, or you can say b square equals to, so a particular side that is looking at this, any of these sides square, the hypotenuse, any of these sides squares is equals to the other two sides, the addition of the other two sides, a square plus b square in this, or plus c square in this case, minus AC cos the angle on B. And if it's C square I'm looking for, if it's C, the side of C I'm looking for, it will be equals to the sides, the sum of the sides of A square and B square minus 2AB cos C. It is from this particular place that you get your Pythagoras theorem, because when you are dealing with 90 degrees, cos 90 is 0. And if you come and put this to be 0, everything here will be 0. You are now left with Pythagoras theorem. So the sides, to find the sides, more like looking at the hypotenuse, is equals to the addition of the other sides. But cosine rule now adds product of the two sides, then cos the angle. This thing I'm seeing here. So now, since I'm dealing with finding the angle, two angles, if it's just one, I focus on calling it the same. But since I'm dealing with finding two angles, I will use this one for A. So that means that the one I'm using is A square equals to B square plus C square minus 2BC cos A. Why am I using it? Because this is the only one that has angle of 2 here. See it, 30, 30. I can divide this to go this, I can divide this to go this. I cannot come and divide this thing now, like from here, and it will be the same. No, it will not be the same. So if I know that, okay, but just have it. But even if you want to rotate it now and say that it's the same, it still makes sense. But the truth is that we are focusing on this side, we are using this side. So since we are using this side, I'll now say that A in itself from our derivation, A is equals to P plus Q. So P plus Q all square is equals to B square plus C square minus 2BC cos A. We'll call it alpha plus beta from this. So B plus Q square is the same thing as saying P plus Q, P plus Q. If I don't want to do this now, I can use my binomial theorem, which is 1, 1, 1, 1, 2, 1. Since the power is 2, I can just say P square plus 2PQ plus P plus Q square. But if I don't want to do this, let's just use this method. So P times P square, P times Q plus PQ, Q times P plus PQ, Q times Q plus Q square. If you add it, you see that you have P square plus 2PQ plus Q square. This is not a class where you learn binomial theorem or how to FOIL. If you want to do that, you check my channel. We're trying to make use of our time proper. Pay attention. You have to pay attention. If you think you are not following me, it's because you are not attentive. You need to go and eat, then come back. So equals to, so everything I've done here is equals to P square plus C square minus 2PC cos alpha plus beta. Put it, always remember to put it in the brackets. But remember that we are trying to prove something that has to do with cos alpha plus beta to be equals to cos squared theta minus sin squared. So for that reason, I need to find a way to make this subject of the formula. So if this cross equality sign, it becomes 2p c cos alpha plus beta is equals to p squared plus c squared. Then if this one that is having positive cross over, it becomes minus p squared plus 2pq plus q square. Anytime you want to put minus in front of something that is carrying different signs, always remember to put positive sign. Put brackets. It saves you a lot, so you don't make mistake, because once you have negative, it affects. So this is equals to p square plus c square minus p square minus 2pq minus q square. Yes, because this minus is on everything here. So equals to 2pc cos alpha plus beta. So making cos alpha plus beta, so that the formula now, cos alpha plus beta will be equals to p square. So p square now, I notice I've cited this. I've seen that from the Pythagorean identity, when you're doing trigonometry, your mind always need to, even at the first place, need to tell you, why did I first draft these things before starting to prove this? In my first class, I told you that every time you're doing trigonometric identity, you hear some people say that there's no standard rule of doing trigonometry. It's a lie. It's very simple. Once you note that there are things like Pythagorean identities, that is from hypotenuse, and there are standard identities, different identities. Why you get all these identities is so that as you are solving anything in trigonometry, you can always replace whatever you come across with an existing identity, and life will be easy for you. You go on. So that is why when I started, I did something like finding all those necessary things so that when I'm solving, I won't have to go back and start stressing, or I won't forget and then be solving myself into confusion. So notice that from here, I see that c minus p, c square minus p square, c square minus p square. Notice from here, I see that c square, when I did this Pythagorean identity, c square minus p square, when I find out the things on the side, is equals to h square. So I will just replace everything here by h square. But before I do that, I will collect this q that is here. So, or you can say plus h square minus 2pq minus q square. So I can go on, because I see again that p square minus q square is equals to something. P square minus q square is equals to h square. So I just do p square minus q square plus this q square plus h square minus 2pq. So collect everything here. You see that is the same as h square. So plus, bring this h square down. So p square minus, so I got it from all these Pythagorean identities I listed out in the first place. Some of you just want to jump into learning everything without paying attention. Better pay attention to all these things. So h square plus h square minus 2pq. Now then remember that everything here, I'm trying to divide everything. Or let me just be carrying my 2pc. Let me be carrying my 2pc until I'm done simplifying. So notice that this is the same thing as saying h square plus h square is the same thing as saying 2h square minus 2pq. So 2pc cos alpha plus beta is equals to this. So to make cos alpha plus beta subject of the formula, cos alpha plus beta will be equals to 2h square minus 2pq all over 2pc. Something is common here, the 2. So this is the same thing as saying 2 into h square minus 2p minus pq. Are you okay? Minus pq all over 2pc. This will take care of this. So that I now have equals to h square minus pq all over bc. And this is the same thing as saying, h times h all over pc minus p dot q all over pc. I'll not teach you LCM. So I can now say cos alpha plus beta is equals to this. So let's now try to check h over b. From when we started, is h over b equals to something? So we can now say cos alpha plus b is equals to h over b. Do we have anything h over b from? Remember, we are dealing with alpha plus beta now. So we go back and look at the sine, the cos of alpha and beta. H over c. We have h over c and we have h over b. H over c is equals to cos alpha. H over b is equals to cos beta. So we have here, remember that this till everything here is the same thing with this. So we have h over b to be cos beta, h over c to be cos alpha. So I can do this way, h over c, h over b. So if I do that, I now have h over c to be cos alpha, h over b to be cos beta. Multiplication is associative. I can rotate it how I want. So it's cos beta minus p over b. Do I have anything like p over b or p over c? Okay, yes, I have p over c. P over c is alpha, is sine alpha. So I can have this to be this way. So I'm looking for what works. Assuming I have p over b, I will go this way. So since I have p over c is sine alpha, I'll do minus sine alpha. Then do I have q over c? Do I have q over c? I have q over b. Then do I have q over b? Do I have p over c? I have q over b, yes, q over b. So q over b, this one now, q over b is equals to sine beta. So I have sine beta. So there you have it. So it's the same thing as saying, see the way I did it now. I moved on to make this. It's because I'm trying to save space. Moved on to make this h over c times h over b minus p over c times q over b. So because that is what I have from the angle. So you can see now that this is cos alpha, cos beta. And since alpha and beta are the same thing, we can move on to say that since alpha and beta are the same thing, we can move on to say that cos 2 theta is equals to alpha and beta, they are the same thing, is the same thing as theta, 30. So this can be the same thing as saying cos² theta minus sin² theta. So we've proved it. So this is why we say that cos² theta is cos 2 theta is cos² theta minus sin² theta, and the one we did earlier, sin 2 theta is equals to 2 sin theta cos theta. So we prove this. So remember to subscribe to my channel. So this is where I did this the first time. The first time I did it when I was trying to study. This is how I went about it. So I want you to screenshot this, write it out, then use it to make your own analysis. I love you. Subscribe to my channel, Academic Daddy. Thank you.